This is semester exam review, problem number 2. It asks us to solve for x. The first thing we want to do is isolate the radical. So we're going to add 1 to both sides. When we add 1 to both sides, we get the square root of 19 minus 3x equals 3x and plus 1. Now we want to get rid of the radical. The way we get rid of the radical is to square both sides. When we square both sides, we have to square 3x plus 1 as a quantity. On the left side, when you square a radical, the radical disappears, and we get 19 minus 3x. On the right side, we're going to rewrite that as 3x plus 1 times 3x plus 1. And then you have to FOIL that. So you get 19 minus 3x equals 9x squared plus 6x plus 1. Now we want to set it equal to 0, so we're going to subtract 19 from both sides. And we're going to add 3x to both sides. And that gives us 0 equals 9x squared plus 9x minus 18. Now 9 factors out of everything, so I'm going to factor out that 9. And I get 9 times x squared plus x minus 3. Now that factors, and it factors into 9 times x, that should be a 2. X plus 2, x minus 2. And then this is x plus 2 times x minus 1. And then we set the individual parts equal to 0, so either x plus 2 equals 0 or x minus 1 equals 0. So x either equals a negative 2 or x equals a positive 1. Now, these are called our possible solutions. They are not necessarily our solutions. We want to always check them. So we're going to go back to the original equation. And everywhere there's an x, I'm going to now put in a negative 2. So I get the square root of 19 minus 3 times a negative 2 minus 1 equals 3 times a negative 2. So that gives me 19. Negative 3 times negative 2 is a positive 6 minus 1 equals a negative 6. So then 19 and plus 6 is the square root of 25 minus 1 equals a negative 6. And that gives me 5 minus 1 equals negative 6. And of course that gives me 4, which is not equal to a negative 6. So this is called an extraneous solution. It does not work. Now it's possible that neither one of them work. They could both work. One of them could work and one of them couldn't. Or neither one of them could work. So we always want to check both of them. So again, we're going to take the x equals 1 and plug that in. So I get the square root of 19 minus 3 times 1, because I'm plugging in 1 for x now, minus 1 equals 3 times x, which is 3 times 1. That gives me square root of 19 minus 3, which is 16 minus 1, which is equal to 3. The square root of 16 is 4, and 4 minus 1 does equal 3. So since 3 equals 3, then x equals 1 is a solution to this equation.